Hello! I wanted to show you this circuit that I designed called the Hireline Motor Controller XL. What it is it's something that you can plug a Raspberry Pi Pico into, like this one, and then you can control a bunch of motors programmatically. And I've done some pretty cool things with it, I have to say, to make it even more fun and more hackable to do this sort of thing. Now, I designed this for my own sake, for some art installations that I want to make, but I have made it general purpose enough for everyone to use it. Also, what I have done with it to make it accessible to everyone is to make it self-documenting. So what I mean by that is that if you take a look around the circuit board, you can see, hopefully, that everything is labeled properly. So you know what all of the pins here do, the addresses of things, and even on the back side here is a bigger explanation of the pinouts, so that you don't actually even need to find the documentation online for this board. You can probably figure it out just from reading on the board itself. And I also just quickly want to say thank you to PCBWay for sponsoring this PCB prototype. That's really great. It's very expensive to make these things and iterate over them, because when you make a mistake in a design like this, you have to send it off to the PCB production facility again. So I'm really grateful for that. So I'll just quickly run over what's on this board and how it works. So first of all, I want to say that you can program this in many different ways, but with these Raspberry Pi Picos, you can program it using, for example, Arduino or CircuitPython or whatever. And I have made a few variations of these boards using the Raspberry Pi Pico. I'll make videos about the other ones too, just because I wanted to experiment with different ways of controlling motors and with different chips and all this sort of thing, to find out what's most appropriate for different use cases. So let me just quickly run over the features of this board. The boring part, but also extremely important part, is the power section. So you can see here it has a power input. It takes between 5 and 15 volts. This is the power that's used for the motors. So if you have like a 12 volt motor, then you can plug in a 12 volt power source. This power source has reverse polarity protection. It's down here somewhere. Which means that if you plug in a power plug the wrong way, which you can easily do, then nothing happens. No power comes into the device. That's really important. Another cool thing about the power is that, as you can see, this Raspberry Pi Pico is lighting up, even though it does not have a USB cable plugged into it. And that's because this power source is automatically converted to 5 volts using this little guy down here, and that's powering the Raspberry Pi Pico. So you only need one power source. On some of these boards, you'll see that you have 2 separate power sources because the motors may be running on 12 volts, but the Raspberry Pi Pico needs 5 volts. But this takes care of it automatically for you. And if you plug in a USB cable while power is running into it, that's no problem either. It will just automatically switch around between the 2 power sources. And so this is now running on a 9 volt power supply for the demonstration here, but you can go up to 15 with this one. And as you may be able to see, the power is broken out as well. So here we have the motor power, so after the polarity protection. So when you plug in a power here, and if it's plugged in the right way, then you get 9 volts here if that's a 9 volt power source. And similarly, the 5 volts that are generated by the board is accessible over here. So you can use that for, I don't know, powering something externally, and then here you have 3 volts as well. So there's a lot of options for powering things with this circuit, which is really nice. Okay, so the main idea about this board is to control motors. Let me just switch this around a little bit. And there are two ways to plug in the motors. At the front there are screw terminals for the two plugs that you usually see on a DC motor. And then behind them are additional connections that I'll get to in a minute. But with this one you can control 4 DC motors at the same time. And for each of them you have control over the speed and the direction of the motors using these 2 chips. You can also put the motors into standby mode as well to make them completely silent. The reason I have these extra pins behind each of these motors is to allow you to plug in motors that have encoders built into them. Some motors come with an encoder built into them to allow you to more precisely determine the speed that they're running at and the position of them as well. And this way that these pins are broken out should make it really easy to just plug it in directly to the board and program it. So these are the 2 motor controllers, and they are controlled using a PWM chip that's over here. And the reason I am doing that's a little bit more advanced than what you would normally see. But the reason I'm doing that is that with this, the control of the motors is done by this chip, and this chip is then connected to the microcontroller, which means that the microcontroller essentially only uses 2 pins to control all of the motors, because that's the connection to this chip. It's 2 pins, and this chip then has 16 connections going to the motors here. So you save a lot of pins on the microcontroller, and you can use those extra pins to connect other hardware or program it with like add sensors or whatever. And you can see all the way here in the back, all of the unused pins are broken out next to a line of 3 volts pins and ground pins to make it easy for you to connect stuff. And then there's 2 unused PWM channels on this chip, and they are here. So if you want to control like an LED or whatever, you can do that with those 2 remaining channels. Up here is this flashy little thing. It's a NeoPixel. So that's an RGB pixel, RGB LED, sorry. And you can daisy chain those, so it has connections to connect to more NeoPixels outside of the board if you want to do that. And then down here we have the second I2C connection to the board. It's got 2.54 millimeter pins out, and as well as a Stemma QT connection to connect to Adafruit boards and whatever. So this makes it really easy to connect sensors and different kinds of things to this board. And another little feature which isn't relevant with this particular Raspberry Pi Pico, but the normal like on-brand Raspberry Pi Picos, they don't have a reset button, which is really annoying sometimes when you program it. So I have added one myself. So over here you have a reset button. So this particular one does actually have a reset button, but normally they don't. So it's over here, and that's really handy. And then the last thing is mounting holes. It's got M3 mounting holes, so you can put it snugly into a box. So the reason I wanted to do this technique using a I2C chip, the PWM chip over here, to save up GPIO pins, is to allow to connect a Raspberry Pi Pico with an Ethernet shield. This one has Ethernet built into it, but you can get these hats that you plug on top to get Ethernet connections, and then you can control the motors over OSC, over Ethernet, which is really reliable and nice. But with this, you can also program it to control the motors using MIDI over USB. So if you plug in a USB cable to your computer, then you can program it to be a USB MIDI controller. And let me just plug in a motor and show you a silly little demo program that I made for this one. And also I should say that all of the hardware and the software for it is open source. You can check it out on the GitHub. And so if you get a hold of a board like this, you can just check out the GitHub, and it has some fully functioning example programs that you can just upload to it, and it does different things. But let me just plug in a motor and show you how it works. Okay, so here it is running an example program where it simply randomizes all 4 motors, and it randomizes the direction and the speed they're running at. Now I only have one motor connected, and it's literally something that I found in the trash, and I connected something to it that I also literally found in the trash. I don't know what it is even. It's something from an electrical socket, I think. A very old one. Anyways, it doesn't matter. Every time you see this RGB LED blink in a new color, which might be a little bit hard on this video to see, but every time it does that, it randomizes the speed and the direction of the motor. That's what this example program does. And you can see this example program on the GitHub page for the circuit. And that's pretty much it. So you can control 4 of these with this board. And one important thing to know about this board is that because it uses this technique of having an external PWM chip, what that does is it frees up a ton of GPIO, so you can easily add like an Ethernet shield to your project. But the disadvantage is that this chip, PCA 9685, I think it's called, it only allows you to make PWM signals up to the frequency of 1.6 kilohertz. And if you run a PWM signal at 1.6 kilohertz in some motors, you will hear like a high frequency whine. And for most purposes, that doesn't really matter too much. For art purposes, it might be a little bit annoying. So that's just important to keep in mind. In this example program, I'm running it at 40 hertz. So it's quite low frequency, and what that does is that it makes the movements a little bit choppy, but at least you get rid of the high frequency whine, and then all you get is sort of like a low frequency purr. It almost sounds like a cat. I don't know if you can actually hear this. Yeah. And I don't know, maybe if you use like more expensive motors than whatever this is that I found in the trash, then it might improve a bit. I have made other boards that directly connect the Raspberry Pi Pico to the motor controllers, allowing you to customize the PWM frequency to go beyond human hearing. And that's really great, but it's, of course, it comes at the cost of using all of those GPIO pins that are now connected to this chip. They would then connect directly to the Raspberry Pi Pico, so you don't really have that much left over to do other things like adding an Ethernet shield, etc. So there's advantages and disadvantages to all of them. I would say that this particular board is really useful for projects where you need to connect a lot of extra things to your motor controller circuits, because everything is broken out and there's so much left over. So yeah, that's it. The Hireline Motor Controller XL. Booyah!